So this is the beginning of the lecture for March 18th or 19th, the second lecture of week 2. When we left off, I had left you with this first set of practice problems to work with on this chemical nomenclature sheet. And so I'm going to start out today by going over these. Now, while you work on these, you always want to make sure you have a periodic table near you, because remember, it's the periodic table that's going to help you to answer these. So, as I indicated previously, you should disregard this first column. We haven't discussed what a valence electron is yet. That's something we'll get to much later. But we did say that we could easily predict the charges that elements will form based on where we find them on the periodic table. So calcium, for example, we find in group 2, and we know that group 2 elements generally form a +2 charge. What other elements would form a +2 charge? Well, pretty much anything else in that column. Beryllium, magnesium, strontium, and barium. Germanium we find in the same column, group 14, as carbon. So carbon would form the same charge, as would silicon. We could also put tin or lead in this column, but recall that tin or lead are a couple examples of elements that actually have multiple possible charges. But what is that charge here for germanium? Just like carbon, plus or minus 4. Sulfur we find in group 16. Group 16 elements form a -2 charge. That's also where we find oxygen. And selenium would also be in that group. Iodine is a group 17 or a halogen, so just like fluorine, chlorine, or iodine, it forms a -1 charge. Cesium, being in group 1, as an alkali metal, similar to lithium, sodium, rubidium, potassium, or cesium, well, cesium is the one we're looking at, will form a +1 charge. And aluminum is a group 13 element. Those generally form +3. And we're looking at things such as gallium or indium. So do metals generally form anions or cations? Metals generally give up electrons, and that means they become positively charged or form cations. Nonmetals form anions. So now in our next table, question 4, we're going to take this a step further and actually identify what the elements, the formulas would be when we put two elements together. So we know in each case that we're going to get the metal that forms the cation, and the element that forms the anion is the nonmetal. So in reality, we can just go straight down each one of these columns and fill these in. So we know that lithium and sulfur, lithium is the metal, and while I didn't specify putting a charge in this column, it certainly wouldn't hurt to do that. So lithium +1. The next group, magnesium, forms a charge of +2. Aluminum in group 13, generally +3. Potassium, like lithium, is another alkali metal, +1. Indium over in group 13, +3. Zinc is one of our unusual ones, and hopefully you remember that zinc forms a charge of +2. And copper is one of the ones that can take on multiple charges. It can be +1 or it can be +2. So it's then all the nonmetals that form the anions. So sulfur 2 minus. And again, we're getting all of this just from the column they appear in on the periodic table. Oxygen, 2 minus. Bromine, -1. Sulfur, -2. Selenium, -2. Oxygen is -2. And bromine is -1. So now we can put each of these together to come up with a formula. If lithium is +1 and sulfur is -2, in order for those charges to balance, we need lithium, we need 2 of them, and 1 sulfur. Magnesium and oxygen, one is +2, one is -2, so those are equal magnitude but opposite sign, so we just need 1 of each. Aluminum and bromine, aluminum is +3, bromine is -1, so we need 3 bromines, which would give us a total of -3, which would offset the +3. Potassium is +1, sulfur is -2, so we need to have 2 potassiums, 1 sulfur. Here, indium is +3, selenium is -2, so we're going to have to go to a total of 6 to get these equal. So we need 2 indiums and 3 seleniums. Zinc and oxygen are like our magnesium and oxygen case. They have equal magnitude, so we need 1 of each. And then copper and bromine, a little more complicated because we have 2 possible charges. So if we are using copper +1, then we'd have copper bromide, 1 of each. If we're using the +2, then we need 2 bromines. Finally, for naming these, remember that when we're naming an ionic compound, we start by naming the metal. So in the case of the first question, lithium. For the name of the nonmetal or the anion, we put IDE at the end. So sulfur becomes sulfide. Again, magnesium is the cation, it stays as is, and oxygen becomes oxide. And we can just go down the list. Aluminum bromide, potassium sulfide, indium selenide, zinc oxide, and copper bromide. The last question on this worksheet, as you'll see, involves some polyatomic ions, and those are something that we will cover in our very next piece of lecture.